This is your linked list, okay? This is your linked list. Your linked list, you call it as list or you call it as self. It's up to you, okay? I don't care. So long you understand, okay? This is your linked list. Inside your linked list, right, there are a few components, okay? If you are doing a single-ended linked list, okay? Single-ended. So that means you only have a head, okay? This head is just to store the address, okay? To store the address of what? This head is to store the address of this list node, okay? Because when you malloc, okay? Listen carefully. When you malloc a list node, okay, when you call malloc list node, somewhere in your memory, okay, somewhere in your memory, right, it will create a structure like this, okay? It will create a structure. This structure, when you perform malloc, it have its own address, okay? It have its own address. This part can understand? Okay. For this list node, right, you need to understand first, what is our list node for? Our list node, right, is used to hold a data inside, okay? This data, right, is just to store a void pointer. Because our void pointer, right, can store any address, okay? Our void pointer can store any address. That's why the data type, okay? The data type is actually a void pointer. This part can understand? And then this next, right, okay? This next, right, is to store another list node address, okay? This next all is to store another list node address. So overallly, okay, your next data type is just a list node pointer. Can understand? List node, you see this, okay, this blue box. This blue box is a list node, okay? Our next data type is just a list node pointer. Because this list node pointer, right, is going to store another list node address. Can understand? Okay, let's see your linked list, okay? Let's see your linked list. When you malloc a linked list, okay? When you malloc a linked list, right, you need to initialize the head, okay? First, you initialize the head. And you initialize the count becomes 0. And we are done. Correct or not? Okay, open your eye big, okay? Now, let me perform insert last, okay? Let me perform insert last. If I want to perform insert last, right, first, I need to malloc. I malloc a list node first, So if I malloc a list node, right, somewhere in the memory region, okay, somewhere in the memory region, this list node, right, okay, you will have an address. I don't know what is the address, okay, I don't know what is the address. This is just set by the operating system. Let's give it an address, let's say 0x first, okay, we first initialize the next become null, okay. When you malloc a list node, right, you need to set the next, because later when we want to iterate, later when we want to loop, right, we need to know when to stop. When we know the next is now, right, we can stop. Okay, when you initialize a list node, when you malloc a list node, you need to set the data first. Okay, you need to set the data and then you need to initialize the next become null. Is this part okay? Okay, afterwards, use your eye to look. Think logically, what is the next step you want to do? What you need to set this address, okay? You need to set this address to head. So you need to change this address, okay? Initially it's null, then you want to change the head address become 0x8, okay? If the head is 0x8, right, okay? If the head is 0x8, we can draw an imaginary line, okay? We can draw an imaginary line. That means, okay, right, our head direction, okay? Our head direction here, okay, this is an imaginary line only, okay, so that means 0x8, our head would be in here, can understand? Okay, again, just now the address is null, right? Okay, just now the address is null, so I set this 0x8 to the head. I update the head, okay, I update the head. So currently the head address will be 0x8. I put this list node address, okay, I put this list node address 0x8 to the head. If I put this 0x8 address to the head, right, you can imagine it, okay, you can imagine it. Our head direction is this green arrow. This green arrow is an imaginary direction. Can understand? What else do we need to do? We need to update the count first. We need to update the count, okay? We need to update the count. Okay, we need to update the count become 1, okay? Now, if I insert last again, okay? If I insert last again, what should I do? You need to malloc a new list node, okay? You need to malloc a new list node. So this is your new list node, okay? This is a new list node. I actually don't know what is the address, okay? I don't know what is the address. This address, right, would be found by the operating system. The operating system will find available address and give it an address. Let's say the operating system give it address as 0x2, okay? 0x2. the next thing we need to do is we need to initialize the next, okay? We need to initialize the next become null, okay? And also, right, your parameter would have the data, okay? You need to update the data to the parameter value also, okay? So you update the data and then you set the next become null. Is this part okay? Then you use your eye to look only, okay? You use your eye to look. What is the next step you want to do? Then you need to start from the head, okay? You need to loop start from the head. You loop start from the head, right? 0x at, okay? Then you follow your imaginary direction, okay? You go to your imaginary direction. You need to see, is it null already? Because your linked list, right, is just not holding one item. When you keep insert last, right, your linked list can be very long, okay? Your linked list can be very long. That's why you need to check whether the next is null. If the next is not null, right, that means this is not the last node. You need to keep looping, okay? Use a while loop, okay? You need to use a while loop. Keep iterate until, okay? Until you met the next as null. This part can understand. You need to go to the last node. Because, right, your linked list can be like this, okay? Your linked list can be like this, 0x at, okay? This could be 0x at, okay? And then your linked list can have, let's say 0x1, this one have 0x, you have a next, and then you have a next, okay? This next, right, can point at here. This next direction is at here. This next is null, okay? When you perform an insert last, okay? When you perform an insert last, you need to start from 0x at, keep going to the next one, okay? You go to the next one, and then you need to keep go to the next one, okay? When you keep go to the next one, when you met the null, okay? When you met the null, then you know, okay? You know this is the last node. That's why, okay? That's why we need to keep looping, okay? We need to keep looping until the next is null. This part can understand? Okay. When you found this is the last node, okay? When you found the next is null, you know this is the last node. When you know this is the last node, right? You need to update this address, okay? You need to update this address, okay? This address no longer is null, okay? So this address is, we put 0x2, okay? We put the next as 0. When the address is 0x2, okay? When the address is 0x2, the imaginary direction, okay? The imaginary direction will be like this, can follow? Okay, after we update our imaginary direction, right? What is the last thing we need to do? We need to update the count, okay? We need to update the count. We need to increment it because currently we have two list nodes. Two list node, that's why we need to update the count now, okay? So the count become 2. Let's see how do we remove last, okay? Let's see how do we remove last. Okay, let's perform a remove last. When you perform a remove last, right, okay, you need to be careful. There are 3 criteria you need to check. First, you need to make sure the linked list is not empty, okay? The first criteria, you need to make sure the linked list is not empty. Second criteria, you need to check, is it remaining? If it's the count 1, okay? Is the count is equal to 1. This is the second criteria, okay? If the count is not 1, then this is the else, okay? This is the else. You need to check 2 things, okay? You need to check 2 things. Is the linked list not empty, okay? If the linked list, how do you know your linked list is not empty? You know your linked list is not empty when the head is not null, okay? You know your linked list is not empty by looking at the head. The head is not null, right? Okay, the head is not. Then you look at second condition. You look at second condition. Is our count is equal to 1? No, okay? If our count is not equal to 1, right? This is our third condition. If it is the third condition, our count is not 1, then loop to the end, okay? You need to start from the head. Let me ask you, look at this diagram, okay? Look at this diagram. If you start from your head, right, how can you go to the end? You tell me. You know, okay? You know. If you want to remove last, right, okay? You want to remove last. If you use your eye to look only, okay? If you use your eye to look, you know you want to remove 0x2. But my question is, how do you get to 2? First, you need to start from the head, okay? You need to start from the head and then follow your imaginary direction, okay? You follow your imaginary direction. You go to the imaginary direction. Is the next null? The next is not null, right? Okay? If the next is not null, then you follow your imaginary direction, okay? You follow your imaginary direction, you check, is the next null? If the next is null, then you know, okay? You know, this is our last node. This is our target, okay? You want to remove this one. When you want to remove this one, right? Okay? When you want to remove this one, one, you want to return the value, don't forget. So you want to return the return value would be this 0x2 data lor. Can understand? When you want to perform remove flash, okay? When you want to perform remove flash, right? You want to return the data inside, you want to return this, okay? You want to return this data. Can understand? Okay. After you return this value, okay? After you return this value, then only you can free this list node, okay? Only then you can free this list. You must store the value first. You must store the data first. Very important, okay? You store the data to this variable first. You must store it to a variable, then only you can free this, okay? After that, what you want to do is you want to free, okay? You want to free this list node, then you want to destroy it, okay? Then you destroy this list node, okay? Before we destroy this list node, okay? Before we destroy this list node, right? Is there anything else I need to? What should I do to this 0x2? What should your imaginary direction become? What should this imaginary direction become? If you delete this list node, okay? If you want to delete this list node, right? If you want to delete this list node, right? What should you do to the imaginary direction? If you want to delete this list node, right? What should you do to this imaginary direction? What is the value you need to set to the next? We update it become null. So we erase this 0x2 first, okay? We erase this 0x2. This 0x2 would become null, okay? This 0x2 will become null, okay? Null. If we put this become null, our imaginary direction also get updated, so our imaginary direction will be here, empty, correct or not? Okay, finally, right? Don't forget, okay? Don't forget. We need to free this list node, okay? We need to free this list node. So we call the free function and destroy this list node, okay? So we destroy this list node, free it, okay? So that there is no memory leak, After we free this list node, right? What else do we need to do? We need to do what to the count? Yeah, we need to decrease the count, okay? So we need to update the count, okay? We need to update the count become 1, okay? Like this, okay? Like this, our linked list only complete. Then we can erase this one, okay? We can erase this one. Can follow? Okay. Right now, okay, let's remove flash again, okay? Let's remove flash again. There are 3 conditions. First, we need to make sure your linked list is not empty. You need to make sure your linked list is not empty. If your linked list is not empty, I should write it like this, okay? I should write this like this. First, the first is the not empty. Okay, if the linked list is not empty, okay? If the linked list is not empty, then only you need to check is the count is equal to 1 or else. You need to check is the count is equal to 1? Is the count equal to 1? Okay, if the count is equal to 1, use your eye to look, okay? Use your eye to look at this diagram. What should we do? If your count is equal to 1, right? When I call remove last, what should happen to this linked list? Yeah, we need to update the head, okay? We need to update the head. So same to just now, okay? Same to just now. Our value, okay? Our value, right? Still this data, okay? Our value is still this data. And then we need to update the head, okay? We need to update the head become what? When we perform remove last, null, okay? Our imaginary direction will become, okay? Our imaginary direction will be nothing, okay? It will be become nothing, okay? After we set the head become null, then we can free this, okay? We can free this, so the list node would be get destroyed, okay? Get destroyed, okay? After we destroy this, okay? After we destroy this, right? What else do we need to do? Yeah, we need to update the count, okay? We need to decrement it, okay? We need to decrement it become 0, and with this, we have done our remove last.